Okay, this week we're going to talk about Lab 4 and the VI that you need for that. And as you can see here, this is what your front panel should look like when you finish the block diagram. The VI. And this is what your block diagram should look like. I'm going to post a PDF of the screenshot of these two so you can see what it's supposed to be, but you're supposed to figure out yourself. So I'm going to show you the settings of the DAC first. So we're going to use the normal voltage using AI0 port. You're going to set your full scale range to 0 to minus 30 millivolts, because that's the output of the strain gauge is in millivolts. You're going to leave your terminal configuration as differential, and you're going to change your acquisition mode to continuous, and you're going to hit OK. Once you hit OK, then there's going to be a dialog box that pops up after it builds it and asking you if you want to create a loop for this. You're going to hit yes. You need to have a loop for this so that we can use the filter properly. And then when you say yes, you're going to get this little outline with a DAC in it, like this. And you can adjust the size you need so you can place all this in there. So what you can do is set all this part up, and you can actually select these things and copy and paste it into the VI when you get to class. So you can make all this, copy and paste it, and then put in your DAC assist after you have everything, and then paste it in, and you can use it. So now I'm going to open a blank VI to show you how to use the filter and the formula block, and how to make some new changes to the saved measurements file so that you get more data coming out of it, so you know more information about it. So the first thing we need a filter with these strain gauge circuits because they fluctuate a lot, and we're going to use a moving average filter. To get a filter, you right click on the block diagram, go to signal analysis, and then you go to filter, place it in there. You're going to wait a minute, and once it's finished initializing, it will show a dialog box asking you the options. Alright, the dialog box has popped up. So here you see the different filtering types. You're going to want to figure these out by yourself. They're pretty self-explanatory. We're going to use smoothing, moving average, rectangular, and we're going to change our half width to 2000, and then hit OK. And the reason why we need a filter is every time this moving average you hit run, it starts at 0, and then the average changes based on the input of the DAC to a new point. So you're going to have a transient regime of where it's not the actual value that you're getting in. So you got to run it continuously over a few seconds to finally wait for it to respond and get to the right level. So once it's finished responding, you'll get basically a flat graph of what value it is. And that's what we want. And what you're going to do is you're going to use those two formula blocks that you saw, and I'm going to show you how to use them right now. And you're going to implement the formula to convert voltage to strain and then strain to Young's modulus. We want you to calculate Young's modulus in LabView right away so that you know if you're getting the proper data or not. This lab is very, very, very hard to get good data. So that's why we want you to calculate everything right away so you know if you got proper data or not. So to use the formula block, you're going to go on your block diagram, right click, arithmetic and comparison, underneath the express VI, click formula. Now I'm not going to put in the specific formula you need. I'm going to show you how to do another type and how to put in exponents so you know how to do that. So on the right here there's this green screen. This tells you if your formula is correct. If there's any missing parentheses or it's incomplete and it's not proper, then it'll tell you by being green. If it's not proper, then it won't be green. It'll be kind of grayed out. So I'm going to change my X label 1 to X and my X2 label to Y, because I'm going to put a formula in of X squared plus Y. So I have X already in there. So then I'm going to hit this double sign right here. That means squared. That means to the power. And I'm going to put my power symbol in. And then I'm going to add, and I'm going to hit input 2, which is Y. So I'm going to hit Y. So that's my equation that I'm inputting for right now. It shows green, so I'm OK. And then you hit OK for it to set it up. And my X value is the value that I'm having coming in from my filtered signal. So I'm going to connect that to that. And then my Y value, I'm going to create a control so that I can change it. Now, if you click on numeric, we can change the label, and I want to label this Y. So this is how you can change labels in LabView. Now, you're going to take the resultant and you're going to display it. So I'm going to display it as a numerical indicator. And then you can also change this. So the output of your first formula block would be strain. So I can rename this strain. That's how you rename those. So again, you're going to use a filter with smoothing. You're going to use the formula block like I showed here. You just enter your equation as normal, and you get all the knowns on one side, and you have the unknown as the other side, because the unknown is basically your resultant. So basically, you have all your known values here that you're going to put into this formula, and then it'll give you out your resultant. So the last thing you're going to need to know is how to use the save measurements file, but I'm going to add a few extra features that we want you to learn about. So again, you're going to go to output, and then you're going to go to write to measurements file, place it in there, and you're going to put in your normal output stuff that you always use. So we're going to use next available file name, one header only, one column per channel, and then I'm going to change it to my desktop to make it easier for me. Again, I recommend you put it on your flash drive to make it easier. So I'm going to just name it test as usual, and then hit OK. And then you know that you put your signals in here. You put the signals that you want in there. You can also merge multiple signals and put them all into one save to measurements file. And then you know how to create a control to enable it. Well, I'm also going to create a control. If you scroll through here, you can see file name. So I'm going to right click and create a control for the file name so that you can determine where you're going to save it. You can change it right here without going into your write to measurements file. I'm also going to put an indicator on my file output name. So this file name tells you the file that just ran, so the previous run file name. So when I run this first one, it'll display this whole thing as test1, test blah blah here, telling you that's the one that just ran. When you run it again, it'll change it and update it, telling you which one you just outputted, so that you know you can write that down and know what's going on. And then I'm also going to create an indicator for this saving data. When this light turns green, it's telling me it's saving data. When it's off, it's not saving data, so that you can validate this disable enable button. Now keep in mind, when you hit enable, it'll start the next run. When you hit disable, it'll start the next run. So it may still show saving data on the current run if you did it in the middle, but then when you run the next one, it won't show you it's saving data anymore. So that's how you can do extra features in LabView. And you can also go through all this. You can expand these and figure out other information about these. I believe you can probably create a control for some other stuff in the filters. You can create controls for all your formulas, so you have everything on your front panel that you need. If you have any trouble with your VIs, then you can just contact your TA. Again, I'm going to post a screenshot of the LabView VI you should have, and you're going to have to figure out the rest on your own. But this is how you use the formula block, the extra features of write to measurements file, and the filter function. So that is it. Ask your TAs if you get any errors or anything like that. You can also email us on web courses, and that's all you need to know for this Lab 4 VI. We assume that you know how to set up the DAX and make graphs and all that other stuff. So good luck.